Assalamualaikum and hi everyone. So today our group will present Mathematics 1 Chapter 5 Vector and Scalar. This is our content, our presentation. First, topic, content, group members, introduction and application of vector and scalar in electrical engineering and mathematical solution with drawing, and conclusion, and also Q&A.
These are the group members of our presentation. My name is Dereli Resti Adrian and my metric number is 07DEE23F1030.
And my name is Al-Saudi bin Arash and my matrix number is 07DEE23F1048.
My name is Dasman bin Normali. My matrix number 07DEE23F1010.
My name is Victor Uji. My matrix number is 07DE23F1004.
Let's start with our introduction. First, vector. Vector is a quantity with both magnitude and direction, represented by an arrow which indicates the direction of the quantity phi, and length which is proportional to the magnitude. In example like velocity, displacement, acceleration, weight, and force. And scalar. Scalar is a quantity processing only magnitude. In example like speed, length, distance, power, and work.
This is the use of vector and scalar in electrical engineering. In electrical engineering, vectors and scalars play crucial roles in describing quantities. Scalars are quantities with only magnitude like voltage or resistance, while vectors have both magnitude and direction, such as current flowing in particular direction or electric field strength at a point. Understanding these distinctions is fundamental for analyzing and solving electrical problems.
These are the example of formulas in vector and scalar that you need to know when calculating them. Firstly, the position of vector, the magnitude of vector, the unit vector, also the operation of vector like the triangle construction method, the parallelogram method, and also apply scalar dot product of two vector. This is how you apply a vector in electrical engineering. For example, this is a DC bridge that we learn in our measurement devices course. And the question is, if it's given the O and the A, also the B and then the C. If A is 3I plus 8J and B is 4I plus 5J and C is 4I plus 5J, and then the question is find AB and the unit vector. Also the second question is the 2 times A and B. Firstly, we do the first question first, A to B. Firstly, we need to know that we need to find the pathway to AO plus OB. So we need, the question given is the value of A is 3I plus 8J, but that is O to A, so we need to change it to negative so that we can get the correct pathway. So for example, this is the solution, and we just put the negative in front of the OA direction. So 3I plus 8J in brackets plus 4I plus 5J in brackets. So we just put the negative in the 3I and the 8J. So it becomes negative 3I and negative 8J plus 4I plus 5J. And then we just multiply it by I and J. So negative 3I plus 4I is I, 1I. And negative 8J plus 5J is negative 3j. And then to find the magnitude of the question is I is power of 2 plus negative 3 power of 2 with them square rooted, and it becomes 10 square root 10, and then just put it in the calculator and it will give you 3.16, and the unit vector of the A through B is I over 3.16 minus 3j over 3.16. And the second question is 2 times AB. So we just put the value of the calculation that we just get from the first question, but you need to times it 2 times. So we just put the 2 in front of them. So we just we calculate the AB first, and then we times it with 2, and then the value is 2i minus 6j. That is all.
So this is the application of scalar dot in electrical engineering. Based on figure below, given A equals to 2i minus 3j plus 4k and B equals to 4i minus 3j minus k, and we need to find OA times OB and the value of theta. So this is the solution for the question. OA times OB equals to 2 times 4i plus negative 3 times negative 3j plus 4k times negative 1. So we got the answer is 13. And to find the value of theta, we use cos theta equals to vector OA times vector OB, and we get 13 divided by modulus vector OA and modulus vector OB. So for modulus vector, we use square root 2 square plus negative 3 square plus 4 square, and square root 4 square plus negative 3 square plus negative 1 square, and we use inverse cos negative 1 bracket negative 13 divided by square root of 29 and square root of 26. The answer is 61.74 degree angle. In conclusion, in the realm of daily life for electrical engineers, vectors, for example electric fields and currents, and scalar, for example voltage and resistance, serve as fundamental tools. Scalar quantity, singular properties, for example voltage magnitude, simplifying measurement and calculation, while vectors, incorporating both magnitude and direction, enable understanding and analysis of complex electrical phenomena, for example electromagnetic fields and current flow. Whether designing power systems, optimizing electronics, or troubleshooting circuits, the combined use of vectors and scalar empowers electrical engineers to innovate, design robust systems, and ensure efficient, reliable electrical functionality in various aspects of daily life, from household appliance to advanced technology.
Let's head on to the question and answer session. These are the example questions that we picked from our maths book Speed Maths. These are the example question. Example 5, given the vector of OA is A plus 3B and the vector of OB is 2A minus B, and the vector of OC is negative A plus B, and the vector of OD is 3A minus 2B. Express the following vector in terms of A and B. The first question is A, the vector of A to B, and then B is 2 times BC. The C is negative C, the negative vector CD, and then 1 over 2 vector CA. And then the other example is like example 1, given that A is 2, negative 3 and 5, and B is negative 3, 1, 4, and then C is negative 2, 7, and negative 6. Find A dot B and find C dot B. These are the the answers that from the example 5, and this is the example from 1. That is all. That is all for our presentation. Thank you for watching. Any question, please comment down below. That is all from us. Bye.